Interstellar is one of the most scientifically ambitious films ever made. Guided by the brilliant mind of theoretical physicist Kip Thorne, it masterfully blends real, hard physics with some truly creative fiction. So today, we're going on a journey to separate what's scientifically true from what belongs purely to the realm of imagination. The film kicks off on a dying Earth, ravaged by famine, relentless dust storms, and widespread crop failure. Now, this scenario isn't based on any single specific prediction. Instead, it's heavily inspired by real historical events, like the devastating Dust Bowl of the 1930s in America. The core idea here is very real. Climate collapse and agricultural failure are entirely possible, even probable, outcomes of severe environmental damage. But the specific blight in the movie, a mysterious pathogen that's wiping out all of Earth's crops one by one, is a fictional device created for the story. There is no real scientific basis for a single blight that could attack such a diverse range of plants. In the film's world, society has largely abandoned science and exploration, forcing NASA to operate in secret, deep underground. This is, of course, entirely fictional. NASA is a very public and celebrated organization. However, this plot point touches on a very real and sometimes unsettling concern. What happens to progress and our future when society stops valuing science and rational thinking? It's a powerful what-if scenario that resonates with ongoing debates about funding for scientific research and education. One of the most iconic and visually stunning ideas in the movie is the wormhole discovered near Saturn. And this is where the line between scientific truth and fiction gets really interesting. Believe it or not, wormholes are technically real, at least on paper. They are valid mathematical solutions to Einstein's equations of general relativity. But that's where the reality ends for now. In the real world, we have never found a wormhole. We have absolutely no idea how to create one, let alone how to make it stable enough for something to pass through. However, the way the wormhole is visualized in the movie as a shimmering sphere, not a flat hole, is hailed as one of the most scientifically accurate depictions ever. Next, we have Gargantua, the supermassive black hole that is the centerpiece of the film's interstellar journey. Gargantua is widely considered one of the most accurate and breathtaking depictions of a black hole ever created for cinema. The physics behind it is incredibly solid. The glowing hot accretion disk of gas and dust spinning around it, the way its immense gravity bends the light from the stars behind I-10, effect called gravitational lensing, and the way it warps the very fabric of space-time are all based on real physics simulations. The one major piece of fiction is the extreme time dilation on Miller's planet. For 1 hour there 2 equals 7 years on Earth. The planet would have to be orbiting so dangerously close to the black hole's event horizon that it would be torn apart by tidal forces. A stable orbit in that zone is practically impossible. Let's talk more about that time dilation on the water planet. The idea that time moves slower near massive objects isn't science fiction at all. It's a fundamental consequence of Einstein's theory of relativity, and it's a measurable phenomenon. This effect, called gravitational time dilation, truly exists near any massive object, including Earth, though to a much smaller degree. So, the science is real. But the movie dramatically exaggerates the effect for storytelling purposes. The 1 equals 7 years ratio serves to create incredible tension and emotional stakes for the characters, but it pushes the boundaries of what's physically plausible. Then we journey to man's planet, with its surreal landscape of frozen clouds, hanging suspended in the air like solid mountains. This is purely fictional. Clouds, even frozen ones made of ice or other compounds, are made of particles. They can't just float as solid, static structures. Gravity would pull them down. However, the idea of planets with extreme cold environments and exotic alien atmospheres is very real. We've discovered thousands of exoplanets, many with conditions completely unlike anything in our solar system. So while the frozen clouds are an artistic invention, the concept of a bizarre and harsh alien world is scientifically sound. In the film's mind-bending climax, Cooper falls into Gargantua and finds himself inside a tesseract, a four-dimensional cube apparently built by advanced beings from the future. Here again, the film cleverly mixes real concepts with pure imagination. Higher spatial dimensions are a serious theoretical idea in physics, particularly in string theory, and a tesseract is a real, well-defined mathematical object, the four-dimensional equivalent of a cube. But the idea of future humans building a time-manipulating structure inside a black hole to save humanity is beautiful, poetic fiction. According to our current understanding of physics, nothing, not even information, can survive crossing a black hole's event horizon. And how does Cooper save the day? By sending messages through gravity across time. Let's break this down. It is absolutely true that gravity affects time and space. That's the core of general relativity. And gravitational waves, ripples in space-time caused by massive cosmic events, are also very real. We first detected them in 2015. But the idea of using gravity to manipulate the past or send complex information like Morse code across timelines is not supported by any current scientific theory. It is a beautifully imaginative leap that connects the science of gravity with the movie as powerful emotional themes of love and connection. In the end, Interstellar is a breathtaking bridge between science and imagination. Its depiction of a black hole is grounded in real physics. Its wormhole is theoretically possible but remains unproven. And its emotional heart, a father's desperate call to his daughter across the vastness of time and space, is pure, powerful, poetic fiction. The movie reminds us of something profoundly important. Space is vast, mysterious, and still largely unknown. And sometimes, science needs a little imagination to help us ask its deepest, most daring questions. Thank you for watching until the end. If you enjoyed this journey through the science of Interstellar, don't forget to like and follow our channel for more deep dives into your favorite stories. And remember, keep your spirit high and your motivation burning. See you next time.